Hello. We'll wait for a few minutes. I think lecture still not ended. Hello, Deepali. Hello. Am I audible to all? Hello. So good morning, everyone. Uh, in last lecture, we have seen the types of air blast circuit breakers. Right? Air blast circuit breaker means we are applying some external air. Means it is a pressurized air so that the arc can be extinguished. So, according to the direction of air, there are different types of these circuit breakers. That is axial blast type means that air is applied or that pressurized air is applied in the direction of that arc. Then second is the cross blast type circuit breaker means that air is applied perpendicularly so that the arc can be extinguished. And third type is the radial blast type circuit breaker. So in this the uh, air pressure is applied radially to the arc. Okay, then we have seen the SF6 circuit breaker. SF6 is the sulfur hexafluoride circuit breaker. So here we are using that SF6 gas, which is having more arc quenching properties. That's why we are using this gas, and there are it is also inflammable. There are different properties of this SF6 gas, and it is very easy and it can be used for high voltages, just like 115 kV to 230 kV we can use for the transmission purpose these circuit breakers. But for reconditioning of this SF6 gas, one more equipment is required. That is only the drawback of this circuit breaker. Otherwise, this circuit breaker is very useful. And one more drawback is SF6 gas is costly, but we can recondition that gas and we can again reuse, right? Then next circuit breaker we have seen is the vacuum circuit breaker. So this vacuum circuit breaker is also having so many advantages. That is, we can use this circuit breaker for almost 22 kV to 66 kV. So that can be at the generating station or for the small transmission purpose. Okay, means if we are simply just upgrading the voltage, or we are uh, means decreasing the voltage. So for these purposes, means in these lines we can use this vacuum circuit breakers. So here a very close vessel is used, and there are other some insulate this is the insulating vessel, and that vacuum is tightened in this vessel only. Okay, so the these are the two contacts here, fixed contact. One is the fixed contact, another is the moving contact. And whatever be the vacuum, when actually we are moving this movable contact, that time that vacuum may get out. But for that purpose, we are using here bellows, so that that vacuum will remain as it is there. And these are the arc shields used here. So this vacuum circuit breaker is also having different advantages. Now, uh, today, the new point we are going to start is the HVDC circuit breaker. HVDC is a DC type of circuit breaker. Whatever types we have seen up to this point, all were AC circuit breakers. Okay, means we can use this only for the AC circuit. Now, this is HVDC circuit breaker. HVDC circuit breaker means specially it is used for the DC circuit. Now, this HVDC circuit breaker is a special type of circuit breaker that is specifically designed to use for the protection against fault current in the HVDC circuits. So we can use this for the DC circuits. So there are, we know that as we are using now the grid system, there are very small generating stations. For example, if we take the wind power station, so that is also HVDC substation. Okay, if you have seen, that is HVDC substation. So for that purpose, these circuit breakers are used for the protection purpose here. Now the major part that differentiate the DC circuit breaker from other type of circuit breaker is the arc quenching technique. Okay, so what is actually the difference between these AC circuit breakers and DC circuit breakers is that, so here, am I audible to all? Clearly audible? Roll number 2, Snehal, Sonal, Dipali and Sangeeta. Snehal, Sonal, Dipali and Sangeeta not yet started. Okay, so I think I'm clearly audible to all. Okay, so here the main difference between these AC and DC circuit breakers is the arc quenching technique. Means we have to extinguish that arc. So how actually? So we know that when we are considering the AC circuit breakers, that time uh, uh, the supply is AC. AC means here the alternating current. Alternating means here after half cycle your current is coming to the 0 point. Okay, so that is nothing but the natural current is 0. Okay, so we are getting a sine wave there. Sine wave means from 0 it is starting. Here we are getting the peak value. Again it is decreasing to the 0. means naturally we are getting the zero current here. Okay, naturally we are getting here zero. But if you consider the DC circuit, so for DC, how is the waveform? For DC, it is a continuous supply. Direct current means it is a continuous supply. So is there any natural current zero? Yes. So when we are using this AC circuit, there is a natural current zero. Means when this current becomes here zero, naturally zero, or that time it is easy to extinguish the arc. Means that arc can be easily extinguished, but it is not possible for the DC circuits, right? For DC, your supply is continuous. There is no natural zero current. Okay, so it is difficult to protect these HVDC circuits. Okay. So these HVDC circuit breakers are used here. So understood what is the main difference? So in AC circuit breakers, it is easier to break the circuit at zero crossing because the energy at that point is zero, which does not allow the generating arc at that voltage level, right? Because here this current becomes zero. Okay, means naturally it becomes zero, and we can extinguish or quench that arc at this point only. But it is not possible for the DC circuit. Okay, because here continuously means it is not becoming zero, it is continuously at its peak value only. Okay, it is continuously at its peak value. That's why it is difficult to maintain the current zero, and that is natural current zero, and it is difficult to extinguish the arc. Okay, so there are some requirements of this for the HVDC circuit breaker. The requirements are this HVDC circuit breaker operation and design is complex as compared to AC circuit breaker due to absence of natural current zero crossing. Right, there is no natural current zero crossing. That's why it is difficult to design such a circuit breaker. So the arc generated in HVDC will never extinguish, and it will heat up the contacts of the breaker and eventually destroy the contacts, rendering the whole circuit breaker useless. Means what happens? So in HVDC, there is a continuous supply. Means no current zero. Natural zero crossing is not there. That's why what's happening. The continuous current will flow through the circuit. Means when we are separating the contacts, the arc will be developed, and that arc is having very high heat, right? Now, so that arc will hit the contact breakers. There are two contact breakers, so these contacts will get heated more, and it can eventually destroy the contacts, rendering the whole circuit breaker useless, and means it may damage these contacts. Okay, if there is continuous arc is there, and that very high heat can damage these contacts also. Okay, so there are different requirements for this HVDC circuit breaker. First is the creation of artificial zero crossing. Means what we can do if we want this current to be zero, or if we want to if the continuous supply is there, and if the supply is continuous, means if your arc is remaining as it is when you are separating the contacts, then there is no use of this circuit breaker, right? So what we have to do? Okay, what we have to do for extinguishing that arc? So we have to create the artificial zero crossing. Okay, we have to create the artificial zero crossing. Then dissipation of stored energy inside the LC circuit. Okay, so actually we know that when we are considering any transmission line, so it is having four parameters: R, L, G, and C. So we know that this capacitor stores energy. So whatever energy stored by that capacitor, so if that capacitor dissipates its energy stored, Then also we can extinguish the arc. Then third one is the withstanding the voltage between its contacts. Okay, means whatever be the voltage, we know that when this current becomes zero, okay, that time the voltage is at its maximum level. So if we maintain that highest voltage, then also we can extinguish the arc. And next is the prevention of this arc restriking. Okay, so what actually happens this in this arc restriking? So when this current is zero, again your arc restrikes here. Again this arc restrikes here. Means some oscillations are there. Okay, some oscillations are there. So this we have to reduce. Okay, this we have to reduce so that we can recover that voltage and we can immediately reach to this natural current at 0 point. Okay, so this arc restriking should be prevented. Then we can use this HVDC circuit breakers. Okay, the strength of that arc is directly proportional to voltage level and the current. So the arc produced in these two contacts of the circuit breaker is proportional to the voltage level and the current. Okay, therefore the fault current must be brought down to zero using an external circuit before breaking it. So means if we break this circuit, the arc will be produced, right? So what we have to do, we have to make this current zero, make the current zero before breaking the circuit, so that when the arc will be produced, it will get the natural current at 0 point. Okay, so that it will get the natural current at 0 point. So everyone is getting what's going on in the lecture? Yes. Roll number 9, Vaishnavi. Vaishnavi. Swapnali.
Yes, Meena.
समझते हैं ना? Okay. Yes, you're not audible, clearly audible. Revati, Payal,
Yes, ma'am.
समझते हैं का? Okay. So these are the requirements of this HVDC circuit breaker. Then working principle. So first we'll see here there is one circuit diagram for this HVDC circuit breaker. So here what we are using, HVDC, simply here plus and minus. Here this is the main circuit breaker between the two ends. Then one capacitor is connected and one inductor is connected in parallel with this circuit, and one switch is there. Okay, this is nothing but the HVDC circuit breaker. Okay, with the main circuit breaker we are just connecting one capacitor, one inductor, that is LC circuit, and one switch. Okay, so what actually happens, so here you can see that this capacitor is having already the stored energy. Okay, the capacitor is used to store energy. So when the current is flowing through that line, that time that capacitor stores energy, and when there is a power supply problem, that time that energy is supplied, or if there is a reactive, if there is more reactive power, that time what happens, this capacitor is used to supply that compensation. Okay, or to give that compensation here. So we are using capacitor in the reverse direction here, because whatever be the stored energy in that capacitor will be dissipated here in the circuit. Okay, So under normal conditions, the switch S is open and the main circuit breaker M is closed and the current flows through it. Okay, means uh, when under normal working conditions, means when there is no any fault, that time this LC circuit is not connected. Okay, means there will be only the main circuit breaker in the circuit. But if any fault will occur, that switch get closed and completes the LC circuit and main breaker M is open there. Okay, so here what's happened, actually this switch is open under this normal working condition. The switch is open and only the main circuit breaker is connected here. And when any fault will occur, okay, means whatever be the current is flowing through this main circuit breaker only. Now if the fault will occur, if the fault occurs, this switch get closed here. Okay, this switch get closed here and this main circuit breaker get open here. Okay, that get open because we know that under normal working condition the contacts of circuit breaker are closed. Okay, the contacts of circuit breaker are always closed under normal working condition, but if the fault will occur, these contacts get open there. Okay, contacts get open. So here during this time, this capacitor start discharging and it pushes the current in reverse direction through the breaker M. Okay, means whatever be the stored energy in that capacitor, so that capacitor starts discharging there and it pushes the current in reverse direction through the breaker M, forcing the arcing current to oscillate and reaching to 0 point, which results in artificial commutation, or it is also called the zero crossing. So this zero crossing or zero commutation is generated by these LC circuits, allows the arc to extinguish at current at 0 point, and the extra energy is dissipated with the LC circuit. Okay, so what is actually happening when this when this fault is occurring, that time whatever be the energy stored by this capacitor is dissipated. Okay, that is dissipated here and it is supplied in this way. Okay, this means the current is flowing here and when you are connecting this LC circuit, that time they are getting the natural current 0 point when this capacitor will discharge there. Okay, means the energy stored will be supplied there and this LC circuit is providing the natural current 0 point. Sorry, it is the artificial zero crossing they are providing there. So these are the HVDC circuit breakers, and these HVDC circuit breakers are used in HVDC plants. Means, for example, if we are considering the grid system, for example, for photovoltaic cells, we are again getting the DC only there. So for such types of uh, substations, we can use the HVDC circuit breakers. Okay, or for such type of supply, we can use the DC circuit breakers. Okay, then next point is the testing of the circuit breaker. Okay, so how actually this circuit breaker is tested? So there are different types of this testing of the circuit breaker. So this testing of circuit breaker is difficult than the testing of any machine like a transformer or any other machine, because the short circuit current is very large. Okay, because we know that we are using these circuit breakers for the transmission purpose also. And if we want to test such circuit breakers, we have to how actually it can be tested. So this testing of the circuit breaker is divided into two groups. First is the type tests and routine tests. Okay, so the type test means type test means whatever different tests we are performing on this circuit breaker, and routine test means regularly what actually we have to test of the circuit breaker or for the circuit breaker. Okay, so first we'll see the type test. So the type test of circuit breaker are, first is the mechanical test. Mechanical test means what? Is there any mechanical damage for the circuit breaker? We have to check here simply. So it is the mechanical ability type test involving repeated opening and closing of the circuit breaker. Okay, means we know that when under there is no any fault, means under normal operating conditions, your circuit breaker should contact should be closed, and when the fault will occur, the contacts should be open there. Okay, so uh, these contacts should be open and closed. Okay, repeatedly. Okay, means as per our requirement, uh, uh, is there operation of that circuit breaker? We have to test, and the circuit breaker must open and close at the correct speed and perform its designated duty and operation without mechanical failure. Okay, means that operation should be within the time only. Okay, within the time only. So this is nothing but the mechanical test, means if there is any fault in the operation of the circuit breaker, okay, means these mechanical quantities are checked there. Then the second test is the thermal test. Thermal test means what? We are checking here the temperature. Okay, we know that when the arc will be produced, that time very high heat will be developed there. So that's why we are using the different materials like oil or air, not only as an arc quenching material but also as the insulating material. Okay, because they can at least keep your circuit breaker to the normal position, because all other factors or all other materials of that circuit breaker also get heated when the arc will be produced. Okay, so these thermal tests are carried out to check the thermal behavior of the circuit breaker. Okay, it is nothing but the temperature of the circuit breaker when the arc will be produced. So the breaker under test deal with the steady state temperature rises due to flow of its rated current through its pole in a rated condition. Means when uh, there is no any fault. Okay, means when there is no any fault, that time the normal current is flowing through that circuit breaker, and with that we have to test what is the steady state temperature of that circuit breaker, and if the current will start flowing through that circuit breaker, how actually that temperature is increasing. Okay, than the rated value, than the rated value. So the temperature rise for rated current should not exceed 40 degree for current less than 800 ampere normal current, and 50 degree for normal value of current 800 ampere and above. Okay, so what is the limit for the temperature rise? What is the limit for the temperature rise? So when the fault will occur and arc will be produced, that time your temperature, if that current, if that arc current is less than 800 ampere, okay, if the current is less than 800 ampere, then that temperature, the temperature of that circuit breaker should not exceed 40 degrees Celsius. And if the current is greater than or equal to this 800 ampere, then the temperature difference should be 50 degree Celsius. Okay, that means that rise should be 50 degree Celsius. Understood? So what is the thermal test? In thermal test, what you are checking? You are checking the temperature. So when the arc will produce, before that, before producing the arc, your circuit breaker should be under normal temperature, that is the steady state temperature, and when the arc will produce, if that arc uh, if that arc current is less than 800 ampere, then the temperature rise should be less than 40 degrees Celsius than the steady state or the normal temperature. And if the current is greater than or equal to 800 ampere, then the temperature rise should not exceed 50 degree Celsius. Okay. So these two tests, first is the mechanical test, second is the thermal test, then third is the dielectric test. So what is the dielectric test? So these tests are performed to check the power frequency and impulse voltage withstand capacity. Okay. Uh, Power frequency and impulse voltage withstand capacity. So we know that when we start extinguishing the arc, so that arc get extinguished means what? Actually, when there is an arc, it is having some ionized particles. So this when we start extinguishing that arc, these ionized particles get deionized there, and the dielectric strength between these two contacts get increased. Okay. Dielectric strength between these two contacts get increased, and the conducting properties of that are get decreased there. Okay. Means the insulating material between these two contacts get increased, and the arc get quenched or arc get extinguished there. Okay. So while performing this test, we are checking the power frequency and impulse voltage withstand capacity. Okay. This what is that voltage at the time of the arc quenching we are checking here, and the test voltage with a frequency of 15 to 100 hertz is applied as follows. So how we are applying actually that voltage? That voltage is between 15 to 100 hertz with a frequency of 15 to 100 hertz. Okay. So it is applied between poles with circuit breaker closed. Okay. When the two contacts of the circuit breaker are closed, so between these poles we can apply. Then between pole and earth with circuit breaker open. Okay. Means any pole and earth, when the circuit breaker contacts are open, then across terminals with circuit breaker open, or when the circuit breaker is open across the two terminals directly also, we can give the test voltage there. Okay. So an impulse test impulse voltage of specified magnitude is applied to the breaker, and for outdoor circuit, dry and wet tests are conducted. Okay. Means by applying that voltage, we are checking means is there insulation created or not between these two contacts. Okay. Means the arc is extinguished or not, here we are checking. That is the dielectric test. Okay. Then next is the short circuit test. So these circuit breakers are subjected to sudden short circuits in. Hello. Yes. Any doubt? Okay. So the short circuit test. So the circuit breakers are subjected to sudden short circuits in short circuit test laboratories, and oscillograms are taken to know the behavior of the circuit breakers at the time of switching in, during the contact breaking, and after arc extinction. So when the short circuit will happen, okay, means any fault is occurring, that time the circuit breaker contacts get open. So whatever be the condition, when we are separating these contacts, and when the arc will be produced and it is extinguished. These are tested by using oscillograms, and the oscillograms are studied with particular reference to the making and breaking currents. Both symmetrical and unsymmetrical restriking voltages and switchgear is sometimes tested at rated conditions. So these oscillograms are studied by taking the reference of the making and breaking current. Making and breaking currents means whatever be the current required to make the circuit and to break the circuit. Okay. Then symmetrical and unsymmetrical restriking voltages and switchgear. So all are tested here in the short circuit test, okay, by using oscillogram. Then next is the routine test. So four are the test type tests. So for this circuit breakers can be tested by two types. That is, first is the type test. It contains the mechanical test. Then what is the second one? What is second one? Mechanical test. Then noting or not? Anyone noting this? Yes, see, mechanical test, thermal test. Remember, mechanical test, thermal test, dielectric test, and short circuit test. Four tests are there in type test, and next is the routine test of a circuit breaker. So, in the routine test, we are checking whether our circuit breaker is operating properly or not. Then the power frequency voltage test, the millivolt drop test is performed to determine the voltage drop within the current path of the breaker mechanism. Okay, so we are checking there the frequency, power frequency voltage. Then the millivolt drop test means if there is any voltage drop in the circuit breaker, and the operational test is performed on the breaker by simulating its tripping by artificially closing the contacts of the relays. Okay, means we are just testing, means when we are closing the contacts of the relay, then only your circuit breaker is operating. So we are manually closing the relay contacts and we are checking whether our circuit breaker is performing or not. Okay, means trip होते का नाही ते check करतात फक्त. So these are the routine tests. Okay, perform. Now the next point is the isolator. Okay, isolator. So this isolator is also one type of a switch. Okay, just like your simple switch, but here we are using this switch is placed in some insulating material, for example oil. So that is the isolator. Okay, means it, and it is used for the high level. Okay, means our switches we cannot use for the transmission purpose, okay, for breaking the circuit, but we can use these isolators for the higher voltages also. Okay, so an isolator is nothing but a switch which is designed to open or break an electric circuit under no load condition. Okay, means if there is no any load, that time only we can use these isolators. Then the breaking of an electrical circuit by isolator is more secure than the circuit breaker. Actually, the it is having the more secure operation for this isolator, because when we are considering the circuit breakers, there is a main problem of the arc extinction, right? So we have to extinguish that arc, and mm, uh, uh, that's why these isolators are easy to operate, and more secure than the circuit breakers. Then we can also open or break the circuit by circuit breaker, but it is not more secure because of the closing and breaking mechanism cannot see directly. Right. Also, we cannot see the direct closing and opening of that circuit breaker because the arc will be extinguished in between these two contacts only, right? So we cannot close or means we cannot see the closing and opening of that circuit breaker. And after off the circuit breaker, the current may flow for the arc phenomenon. Okay, means even we separate the contacts, the arc will be struck between these two contacts of the circuit breaker. That is the disadvantage of the circuit breaker. So for isolators, there is no such a problem. This is a simple type of a switch. Here we can simply switch on, means open the contacts and close the contacts, and there will not be any arc produced, but this can be used under no load conditions only. Okay, and these two are the symbols of this isolator. Isolator means one separator here. Okay, this is a single break isolator, and this is double break isolator. Okay, double break isolator. So समजले isolator means what? It is a one type of a switch simply. Okay, now there is some difference between this isolator and circuit breaker. So first difference is an isolator is a switch which is designed for no load operation, right? Means there should not be any load connected to the system, then this isolator can operate. Then circuit breaker is a device which is designed for on load operation, but circuit breaker can operate even if the load is connected to the system. Okay. Then second difference is the isolator cannot break the circuit when fault occurs, right? Means there is no any sensing device that fault is occurred there, right? So means we know that when we are considering our switch simply, we are using protecting device as a fuse there, but that switch is not getting automatically open, when the fault is occurring. Likewise only for isolators also, if the fault will occur, this isolator cannot operate. Okay. Then for circuit breakers, if the fault is occurring, then circuit breaker automatically disconnects the circuit. That is the advantage of the circuit breaker over isolator. Then third is there is no uh, arc is produced in the isolator, as it is operated at no load condition. Okay, means load is not connected there. Okay, load is not connected means there is no any problem of any type of a fault, that is the, for example, short circuit fault, etc. Any type of a fault, if no any load is connected there, so the arc will not also be produced in these isolators, right? Then circuit breakers. For circuit breakers, the arc will be produced in the circuit breaker as it operated on a load condition, right? We are using here the loaded circuit breakers. That's why the arc will be produced, or arc will be struck between the two contacts of the circuit breaker. Okay. The next is the isolators are operated manually. Okay. So there is no any automatic operation. Uh, we can isolate any circuit, right? uh, Manually. Then there is no relay for circuit, sorry, this is for isolator. And for circuit breakers, we can operate it automatically or manually, right? because if the fault is occurred, the circuit is breaked automatically there. Okay, circuit is breaked automatically. And if we want to disconnect manually, then also we can disconnect. If we want to make the circuit, then also we can make it. Means for circuit breakers, we can make and break the circuit either automatically or manually, or we can say that by remote control only. Okay. Then the fifth difference between this isolator and circuit breaker is there is no relay required for the operation of isolator. Okay, means no any device will be required for the operation of the isolator. This isolator itself working as okay, but for circuit breaker we need relay. So if there is no relay, circuit breaker will not operate, right? How it is? Can anyone tell me? If there is no relay, the circuit breaker cannot be operated. So can anyone elaborate why it is? Because we have seen all relays and circuit breakers also. Yes, anyone? Why the relay is necessary to operate the circuit breaker? Yes. Pratidnya? Pratidnya? Jairam? Saurabh? Sakshi? Roll number 31, Sakshi. Anyone else? Why the relay is required for operation of circuit breaker? Anyone present in the lecture? Yes. Ashwini? Who is present in lecture? Suvarna. Okay. So can you tell me why the relay is required for operation of circuit breaker? Or can circuit breaker operate without relay? Yes, anyone? Swapnil, Shivaji? Deepak? Deepak connected 2 times. Okay. I think no one is present in the lecture. Right now? Okay. So concentrate, because here this circuit breaker cannot work without relay, because this relay is a sensing device, right? This relay is a sensing device. When any fault will occur, that fault will be first sensed by this relay, and then the signal will be given to the circuit breaker, that the circuit breaker have to open the contacts. Okay, that's why this circuit breaker cannot operate without the relay, right? Then the next difference is the isolators. For isolators, the breaking capacity is very low. Okay, means the currents that should be braked when the fault is occurring, that breaking capacity is low for the isolator, and the breaking capacity of the circuit breakers is very high. Means it can interrupt or it can extinguish the arc of the current that will be produced by very high value. Okay. So this is the difference between the isolator and circuit breaker. So this difference can be asked in examination for 4 to 6 marks. Okay, for 4 to 6 marks. Okay. So इथेपर्यंत समजलंय का सगळ्यांना? Any doubt? Any doubt?
No, ma'am.
Okay. Now the next point is the earthing switch. Earthing switch. Now this is the last point of our chapter, earthing switch. So this earthing switch is simply one switch we are connecting, and this switch is connected to the ground. Okay, means if any fault current will flow, that will be given to this earth. Okay, that's why this earthing switch is used. So this earthing switch is used to ground the residual charge in the power lines after disconnecting the line from the source. Okay, so what actually happens? Is anyone having idea about residual charge? Yes, residual charge. You have seen the residual magnetism. You may have studied in basic electrical engineering or in machines also. Residual magnetism. Yes. Likewise, there is a residual charge. So I'll explain that. What is actually that case? So when we are operating any circuit, that time means suppose we are connecting and disconnecting. So when we disconnect any circuit, what actually happens? There are different types of parameters. They get disturbed there. Okay, these get disturbed there. So we know that when the current is flowing through that line, it is nothing but the flow of charges. So when you disconnect that circuit, okay, means the flow of charges get braked. At that time, what happens? They flow means there is a reverse direction, means just like your loop. You may have seen the hysteresis loop. So in that, how is that loop? This is your path when mm, uh, you are giving the flux or you are giving the input. That time your flux get increased. But when it gets saturated, that time what happens? They get in the reverse direction. So just like this, your hysteresis loop is there. Okay, so like this only. Okay, like this only, the residual charge of is there. Means when you are disconnecting the line from the source. Okay, when you are disconnecting the line from the source, that time whatever be the charge or there is a flow of current, means that residual current, where it will go, we don't know. So that will be given to the ground, to the ground. Okay, so by using this switch, that is nothing but the earthing switch. Okay, so this earthing switch is used to ground the residual charge in the power lines after disconnecting the line from the source. Okay, so when a circuit is broken or open by the circuit breaker and isolator, there is residual charge remaining in the circuit. So when we disconnect or when we break or open the circuit breaker get open. Okay, means it is nothing but the two contacts get open, means we are isolating something. Okay, or when this isolator switch is used, means we are just disconnecting the circuit. So there is residual charge remaining in the circuit. To discharge the charge, earthing switch is used here. Okay, earthing switch is used, and during maintenance period, the circuit breakers and isolators are kept open, and earthing switch is kept closed. Okay, so when we are doing any maintenance of the circuit breaker and isolator, that time we are opening these circuit breakers and isolators, and we are just closing the this earthing switch. Why this earthing switch is closed? So whatever be the current in that line or in that circuit breaker or in that isolator is there, so that will be or that will flow towards ground by using this earthing switch. Okay, and in substations, circuit breakers, isolators, and earthing switches are connected. Okay, so actually there is a sequence for the operation of this circuit breakers, isolators, and earthing switches. So first there is isolator, then circuit breaker is there, and then earthing switch is there. So when this circuit breaker and isolators are open, that time this earthing switch is closed there. Okay, that earthing switch is closed there. So in this way we have to check for the sequence also when we have to operate. Okay, so this is the last point of your chapter, that is earthing switch. In this way our sixth chapter is over. So that is the types of circuit breakers. Okay, so समजलाय का हा चॅप्टर? समजलाय का? Yes, anyone?
Yes, ma'am.
Okay. So in this chapter, we have seen different types of these circuit breakers. Okay, mainly these circuit breakers are classified as AC circuit breakers and DC circuit breakers, right? So we have seen these many types of the circuit breakers here. Okay, and there is compulsory questions on these circuit breakers and very useful. So we have seen AC, DC circuit breakers, high voltage and low voltage circuit breaker, then oil circuit breakers and oilless. In oil, bulk oil, low oil, that is minimum oil, and in oilless, air brake, air blast, SF6, and this is vacuum circuit breaker we have seen, right? And after that, we have seen the HVDC circuit breakers. This is all about the circuit breakers. Then we have seen the tests which are performed on the circuit breaker. Right? Then we have seen the isolator, what is mean by isolator and what is mean by the earthing switch. Okay. So this is very simple, easy chapter to understand, and mostly the questions are asked in examination. Okay. So our sixth chapter is over here. Only one chapter is remaining. That is the over voltage protection. That is a small chapter but important one. Okay. So we'll start this chapter in the next lecture. Okay. So if any doubt is there, you can ask me. Sonal. Sonal, roll number 18.
Yes, ma'am.
Any doubt? Any doubt?
No, ma'am.
Okay. Which chapter we completed now?
6.
Sixth chapter. Okay. What is the name of chapter? Types of circuit breakers. Okay. No problem. Study well. Okay. Last chapter is small, and we'll cover this chapter in the next week only. Okay. So thank you all and have a nice day. We'll end lecture now. Thank you.